and welcome back to AWS OnAir. Hello, friends. How are you all doing? My name is Darko, and today I have an amazing guest with me and also an amazing topic we're going to be discussing. I'm here joined by AJ, and we're going to be talking about serverless and Rust.
That's right.
Because everybody needs to learn about Rust, and absolutely everybody needs to learn about serverless. Before we kick it off, AJ, tell us who you are, what do you do, well, you're joining us from here. Who are you, what do you do, and what is objectively the best programming language in the world?
I am so glad you asked, Darko. Hey, everybody. My name is AJ Steibenberg. I'm a staff engineer at Datadog. I work on serverless stuff there, and I'm also an AWS hero. And I'm really excited because Rust is my favorite programming language to work in, especially when I'm working in Lambda. I'm really excited to share that with you. There's a lot to talk about. You want to kick it off?
I want to kick it off, friends. By the way, friends, we're going to be dropping a little a little poll in the chat. We want to hear a little bit about you, because we're going to be talking about serverless, and we're going to talk about Lambda functions, and we're going to be talking about programming languages. We want to hear what is your favorite AWS Lambda runtime. Is it Python? Is it JavaScript? Is it .NET? Is it Rust? Is it something else? If it is something else, drop it in the chat. Did you know you can run Pascal in Lambda?
I did not know that, and I feel like I'm worse off for knowing now.
Somebody made a Lambda layer that you can run Lambda. So, the link is going to be in the chat. Go ahead and give us the answers to those questions, and we're going to come back to it at the end of the show. So do not go anywhere. Okay, let's talk about first of all Rust.
Yes, absolutely.
Why Rust?
Why Rust? That's a great question. I think when you're looking at the landscape of languages you can pick for your Lambda functions, I think Rust comes up as a really, really important one. And I think there's really three major reasons we pick it.
Yeah.
I think the first is that in Lambda, if you crash a little bit, it's really hard to recover, especially if one process dies. Or for me, I'm also a Lambda extension developer. If that extension dies, that can actually kill the running Lambda function, the running Lambda process, and we really don't want that to happen.
Yeah.
Rust makes it really obvious where your function can exit or panic. You have to handle that explicitly. Sometimes that is a little painful, but chat, let me tell you, we can work through it together. The second thing is the performance, right? Right out of the gate, you're getting really, really fast performance. It's a low-level compiled language, but it's got a bunch of high-level primitives. We'll talk about that as we get into the actual code demo.
Yeah.
So it's both really approachable and really, 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 really performant. And the final is footprint. Lambda functions typically limited to 250 megabytes in size if you're using the zip-based Lambda function. If you're using a container-based function, you can go up to 10 gigabytes.
Yep.
However, the smaller it is, the faster it loads. So if you want to minimize your cold starts, which is one of the biggest, most painful things people come to talk to me about, AJ, how do I fix my cold starts? How do I fix my cold starts? And I always have to hold back without saying, like, just write it in Rust.
Yeah, exactly.
Yeah.
Exactly. There is a slight learning curve for Rust, and I'm sure folks in the chat know that. But trust me, in the modern world of generative AI, of coding assistants, of all of the things you can use to learn this, it is actually the most safest language to write. Here's a lukewarm take. It is better to write Rust with a coding assistant than it is to write Python, just because it's safer. The compiler is going to catch most of the mistakes you make.
That's right.
Or something else makes.
Yeah.
So give Rust a shot. And we're going to show you quickly how you can actually use Rust to build serverless applications. But I want to talk about this specific concept of Rust you mentioned, is handling errors.
Yes, exactly.
And panics. This is a thing that some languages have, but not all of them have. So tell me, why is this? How does Rust do this, and why is this important?
Yeah, that's a great question. So Rust explicitly requires you to handle errors from anything that may fail.
Yeah.
So it returns you could think of it like a tuple, right? Like a result object is what we kind of call it, or an option, and it comes back with either the result or an error, and you have to actually handle that error. If you don't, the process will by default crash, and that is really painful when you're working and starting locally. But once you get over it, you actually realize how many things can fail, and you handle them really gracefully. And why that's important. So I work at Datadog. We just got done shipping one of the most exciting things that I've worked on in a long time, and that is our brand new Datadog Lambda extension. It's next generation written in Rust for Lambda from the ground up. And we picked Rust for these reasons, right? We wanted the great performance, we wanted the crash safety, and we wanted to make sure we had really low cold starts. So if we could get the screen pulled up, I can show you a little bit about it.
Let's see what AJ has to show. So,
all right. So you can see the date. We just published this today. It's really exciting. This is brand new, like I said, ground up, built for Lambda, for serverless. It is a Lambda extension that lets you connect to Datadog's monitoring solution. So we can ship logs, metrics, traces. We can ship profile data, all of this along with this new extension. It's really, really, really fast. And in fact, it's so fast, you can take a look at what we're able to get out of it. We were able to go from a cold start time averaging around 450 milliseconds to about 50. I'll show you a graph of that. It's real. I'll show you in just a second. We also were able to have our overhead. This is, you see on the left is the sort of before of the memory impact and the after. So the less resources that you use in an extension, the more resources are free for the Lambda function itself to run.
So this is a JavaScript Node.js Lambda
in this
function.
specific screenshot,
right.
yeah.
But this is when you switch over the actual extension, which
Correct.
is written in Rust. So, right, okay, makes sense.
So previously it had been built in Go, and it was a version of our kind of our main agent from everywhere, and it kind of can run everywhere. And in this case, what we looked at when we realized that our serverless customers really needed something purpose-built for Lambda.
Yeah.
And then on the right, you can see where that dropped. And the same thing is true for the cold start duration. And this is across all runtimes. You can see a very dramatic drop from that 450 mark down to around that 50 or so mark. And it's across all runtimes. So it's an immediate performance benefit everyone can get. But should we show them how to do it?
Let's do it. AJ is going to build a Lambda function right now using Rust. We're going to show you how actually simple it is. Now, again, once you get through all the weeds of Rust and borrowing systems and all those things, once you get all that figured out, it's actually easier to create Lambda functions in Rust.
I think so.
Than Python.
Yeah. So today we want to plug a really cool community project called Cargo Lambda. What Cargo is the package manager and CLI tool for Rust-based for Rust programs, and you can write your own version. In this case, it's like a command. So Cargo Lambda will create a new Rust-based Lambda function for Cargo, and we can do that right now. So let's initialize a new project.
So yes, boom.
Cargo Lambda init -- is it name? Name.
Yeah.
Yeah. Right. Yep.
--
name Darko stream. Let's do it. Is this an HTTP function? I think it should be.
Yes, HTTP function.
So we get a nice little workflow here. We're going to trigger it by API gateway or Lambda URL. This is going to give us the right types for this, right?
Yeah.
So let's take a look at what we get. Any Rust project, right off the bat, you're going to kind of see two things. You're going to see a cargo.toml file, which is going to give you your dependencies and specification for the name of your package, and if it's going to be a crate type package or an actual binary.
Okay.
Then you'll actually get a source directory. So let's use our favorite editor, NeoVim, and crack it open.
Yeah, look at that. Wonderful, wonderful. Awesome.
Oh, wow.
So there's a lot of stuff here, right?
There is a lot of stuff here.
So it does seem kind of challenging at the onset, right?
Well, let's talk through it, because I think the bark is worse than the bite here, Darko.
Exactly.
This is a really exciting, really easy thing to do. What we're going to do is just define a Lambda function handler. Now, if you are not new to Lambda, this will be familiar. This is just a regular function, a regular method that will be called. And what we're going to pass it is the event. These events are... they're well-defined. They're well-defined structures that are available in any runtime. And what we're going to do is return something that may look a little weird, which is a result. So this result type can either return something successful, and then you can access it with OK. Or it will return an error, which you can access with error. No matter what you do, you got to handle both, Darko. That's the crash safety.
That is the beautiful part of Rust. Once you learn about that thing in Rust, you're not going back.
And you'll see it everywhere, like you do right here on line 9. So we're going to try and get the first name of someone, right?
Okay.
But that might not exist, because users don't always do what you want, Darko.
Of course.
So you've got this one little method right at the end that says unwrap or. Now, the beauty of unwrap is if something isn't there, it will actually return the or statement. But if you don't have that, it will crash. So the handy part about Rust now is anywhere you look where you find an unwrap, in your head you're thinking, oh, that's where my program could exit in an unhandled way. I should handle that. So linters really plug in and say, okay, you can't have any unwraps anywhere. You can't have any expecs everywhere. We'll talk about that in a second. But the idea is we want a well-formed string for a message here. So we can say, hello, who it is, right? If they pass a who. This is an AWS Lambda HTTP request. So like I said, at first it seems a little counterintuitive that you have to handle like everything that might fail instead of just maybe get a nil back. But guess what? Nil doesn't exist in Rust, does it, Darko?
Yes, there is no nil in Rust. Remember that, friends. That's one of the quirks of the language. There's no nil, and once you learn how to figure that one out with the option enum, that's where you get to solve all of these kinds of problems. So, yeah. What do they call it? Nil is a $1 billion mistake.
$1 billion mistake.
$1 billion mistake. Yeah.
Fantastic articles too.
Fantastic. Okay.
So what else do we have to do next? So we've got our well-formed string. We know it's well-formed, right? We've guaranteed that. So now we have to build a response.
Yes.
So this is a pretty typical pattern you'll see in Rust. Is like a builder pattern. It's going to allow us to instantiate a new response with a couple of kind of empty fields, and then we have to build them out. And at the end, we can call like build, or in this case, map error. So this is kind of the successful part. If we have the body, we'll take that message, we'll convert it into our response, and otherwise we'll convert a new error.
Yes, exactly. Because you can actually return an error, and you get something that's other than just a panic. So.
Yeah, exactly. Of course, like in theory, someone could send a string that somehow misses the escape sequence, right? And then it's some malformed binary that we can't write out to the JSON blob.
Exactly.
So,
Okay.
now the final thing I do want to hint at is we talked about returning a result here. Now, like I mentioned, we'll pull up our little IntelliSense. We can return an OK or error. That's what we can call in this method. So the result expects us to call one or the other. Did this succeed or fail? And that's what we call, and that's how we can pass that back to callers. And right here on the end, just like you'd expect, we're calling OK with the response.
Yes.
So again, if you were already building Lambda functions, yes, you can do it much shorter in something like JavaScript or Python. That's true. However, I think this is definitely much safer and, as I'll show you, much, much faster.
Exactly.
Should we try to see if we can do this live?
Let's go for it. Is there a main function, by the way? This is my question. Is this all? This is all the Rust function? There's no main function?
There's a main function right down
okay.
here.
Yes.
Yeah.
Okay.
And we can talk about this in a little bit.
Okay.
Toke.io is what's called an asynchronous runtime
Yes.
for Rust. It's a
Yes.
very, very popular package. It's the type of thing you can sort of equate it to Node.js's async runtime a little bit. It allows us to use async await semantics, and it allows us to run concurrent process. I'm sorry, it allows us to run concurrent code on one processor at a time.
By the way, kudos to you for pronouncing Tokayo correctly, because it's not Tokyo, it's Tokayo.
I know.
Just so you know.
In my head, it's always Tokyo.
Yeah, I know.
But that was a tough one to correct.
Yeah, I know.
So let's give this a rip. So let's see, cargo deploy. I think we just have to do cargo lambda deploy. So export AWS profile equals personal. Okay.
Okay.
Ship it.
Ship it.
Oh, sorry. We have to.
Build,
So we do have to build first.
Yes.
That's my bad. My bad, chat. Probably getting lit up in there right now.
So again, what happens here? It actually compiles the application. Unlike Python and JavaScript Lambda functions, this is being compiled into a binary.
It is.
You're not shipping just the code and hoping something else interprets it. You're actually compiling it into an actual binary that is going to be shipped to run under a Amazon Linux 2 runtime. So that's kind of there's a lot of plumbing around it, but you don't have to worry about it at all with the Cargo Lambda.
Yeah, and today, and that's one of the best part about the Cargo Lambda projects, right? Is that today so many of our development machines may be on a different instruction set architecture from the actual machine we're running our code on, from the actual Lambda function. And in this case, I've got an ARM-based processor in this machine, and I have to actually cross-compile it for x86, which is where it's going to run on Lambda. Now, Lambda does have excellent support for ARM builds under their Graviton chip. You also get really good performance and cost improvements, so worth checking out. But in this case, I wanted to highlight the cross-compilation features that are built into Cargo Lambda. You can see right here in the target output file, it's got this x86 unknown Linux GNU build.
Okay.
That's what we're going to ship.
Okay, nice.
Shall we?
Love it. Let's do it, yes.
Okay. So Cargo Lambda deploy. Second time's a charm.
Boom.
It's going to grab that binary data, it's going to slurp it up into a zip package, and it's going to create a Lambda function. Once I make sure that I have the right permissions, which I sure hope I do. It's my AWS account, so I should.
So one thing you're going to notice here, for folks out there building this thing in the wild, is that if you go into the Lambda console, you're not going to see the code.
Correct.
Yeah,
correct.
You're not going to be able to edit this code in the Lambda console in this wonderful new code editor. You have to do it locally.
Let's pull it up. Let's pull it up.
Yeah, let's actually
I think that's important to highlight. This won't be available in the code editor, although that is a lovely, lovely feature that's available in Lambda now, and it did just get a lot better.
Yes.
But we are shipping a compiled binary, so it's super, super teeny. Let's go ahead and look this function up. We've got it right here.
Yep. Can you zoom in slightly on that one
Yep,
so we can
of
see it
course.
better? Thank you.
Look at all the curves and the bezels on the new AWS Lambda console.
Shout out to the console team. Shout out to the console team, yeah.
Yeah, so there's this little bootstrap script. This is actually our binary file. That's what it becomes. So it gets compiled into that. Lambda needs that to kick off the process.
Yep.
But let's go ahead and actually let's add a function URL to this.
Yep.
We'll go to configuration. Let's go to, can we add function URL? And we'll do that really quick. Create. No auth type. Chat, feel free to invoke it. Darko's picking up the tab.
Yep.
All right, so now we've got our function URL. So there's only one thing to do, and it is not plugged into a browser chat where we are going to use the command line.
Oh, of course, curl. HTTPI, you know HTTP or HTTPI?
Yeah, the HTTPI tool. Yeah, I've tried it out.
Nicer than curl. Well, prettier than curl.
Well, let's take a look at this. So we didn't provide any query, did we?
No. Yeah.
So our string fell back like it was supposed to, right? So instead of throwing an error and saying the user knew who they're supposed to do, we've got an actual good fallback path, and we have to handle that in all of these cases. And that's what's going on right here. So let me remind myself about my own code because I forgot what the parameter is. It's world. Okay.
Yeah.
So then we can do curl and then question mark name equals world or
Darko.
okay,
AJ.
Darko.
No.
We'll do Darko.
Okay, sure.
Look at that.
Look
See,
at that.
and this works. And this is just a simple example, of course, of a templated parameterized string.
Yeah.
It's very trivial. It's also a very simple example of using Cargo Lambda. But Cargo Lambda, it doesn't just stop here, does it, Darko?
Doesn't stop. Nope.
No.
A lot more features to it.
Yeah, so there's a lot more here, and I think a lot of folks in chat are probably thinking, because I'm not looking at chat, they're probably thinking, well, wait a second, I have a lot of different tools that I use in my day-to-day workflow. I might not use just this one CLI tool to build all my Lambda functions. I have IAM permissions. I have SQS queues to build.
All of those things, yes.
Yeah, I have topics. I have work to do here, Darko. I have work to do. So Cargo Lambda also can act as a drop-in build tool for your CDK template, and it's got already a CDK construct available. You can install it as a dependency, and when the CDK bundles and packages your Lambda function up, it can call Cargo Lambda to handle that cross-compilation for you. You don't have to worry about any of that stuff. And let me tell you, that's a little bit of a pain, but that is all ready for you right out of the box. Should we take a look at that?
Let's do that, because actually I've never deployed the Lambda function, Rust Lambda function using Cargo Lambda using the CLI. I've only done it using the CDK. So that's kind of how you do it.
Yeah, so we'll take a look at that, and then I'm going to take a few minutes to talk about the performance of what we just saw.
Yes.
So for those who are unacquainted with the terminal multiplexer TMUX, I just switched to a new project. We can actually close it out. So this is a project that Darko and I worked on stream not too long ago.
Oh my God, it's been a while. Yeah.
It's a normal CDK project, like you may have seen. So let's actually open it up. And Rust Lambda is the name of the CDK project, and then the code is somewhere else.
Yep.
So in here, we just have this is actually a TypeScript stack.
Yep.
So I'm adding some Datadog things. We're adding our extension. This is when we were testing out our new, brand new low latency Lambda extension.
Yes.
So you're able to actually modify all these things yourself. So like you saw earlier, I had to jump into the AWS console to create a function URL when I was using Cargo Lambda, and that's fine when I'm testing things out, but I probably don't want that when I want to maybe roll it out to production somewhere. So I can just use the regular CDK, just like this, and just add a function URL. Super, super simple. But your code, the best part is, doesn't change, right? It's right here. This is just a normal Cargo Lambda project.
Exactly.
You've got your same types just like before, and in this case, I added tracing to this, so there's like a little bit of a different main process.
Okay.
In this case, we register OpenTelemetry, and we can talk to Datadog's new Lambda extension. And then at the same time, we were doing a little bit more. At this time, we were talking about some baseball stats.
Exactly. We were actually getting some data out there.
So this project is ready for you if you want to jump in and grow or jump in and try it out right now. And if you want to grow it and you want to put it into your full CDK stack, you can do that too.
Yeah.
Now, should we talk about performance?
Let's talk about performance. Yes, let's do it. Yes.
Okay. So real quick before we have a few more things we want to plug. You just saw how fast a brand new function took to cold start. And if you are a Node.js developer or a Python developer who's not using the brand new Python Snapstart feature, you may experience a couple hundred milliseconds of latency in the round trip cold start request time. Let's take a look at what this was in actual inside of AWS Lambda.
It's fascinating.
We'll pop over here and we can take a look. Now this is just hello world, so I don't want this to be the only and true benchmark. And when I do these and I do these on my stream, it's not the only thing we look at, but it is kind of the first thing you can look at. So let's look at this init start. We'll make this a little smaller. So we're running on provided Amazon Linux, and then we say that we get this start and then end. And all of these were pretty quick, right? We're still in the third second. The entire duration was 148 milliseconds, and 80 milliseconds was our init duration.
Crazy.
And this is a 128 megabyte Lambda function. It's using a fraction of a vCPU core to do all of this.
Exactly.
So if you have a really, really high throughput API that you're trying to really get the most out of, rebuilding parts of that in Rust can actually save you a lot of money too. Tons of money, tons of performance. What's not to love? Now let's talk about how you can learn more.
Exactly. So I want to do a couple things here. So folks, if you want to go and learn Rust, our friend Luciano is actually an AWS hero, is writing a book for creating Lambda functions in Rust. I'm going to drop a link in the chat, by the way, so you all can pick that up. It's currently a work in progress, but it's a great resource for you to learn, to build stuff, to save money by running Rust on serverless. AJ is doing some help. He's working with Luciano on that to make sure that it's all correct and done. But I do want to see the results of our wonderful what is it called?
The poll.
I want to see
Let's take a look.
What is the favorite runtime of folks out there using Lambda, and looking at the results. Python.
I mean, no surprise. It's the OG. And this is actually more or less the order I thought. I am really proud for the 13% of you that chose Rust. I also think .NET's a fantastic runtime. Don't get me wrong.
Absolutely.
But I'd love to see that Rust one go up the next time we do this.
Exactly. Next time AJ and I show up on the stream, I want to see those numbers go up. Yes, and those numbers go down. The init times will go down.
That's right. Bring those cold starts down. Bring that usage time up.
Amazing. If you want to learn more, definitely go check out the blog. I posted a link in the chat as well to AJ's blog, and also posted a link to Luciano's book. Definitely go check that out. Oh, speaking of checking stuff out, wait, I have a thing. This.
He printed a QR code.
Printed a QR code. This, my friends, is a QR code. You are going to go take out your phone and scan it. You're going to create a builder profile. Yes, a builder profile. It gives you a lot of stuff. If you're at reInvent, you actually can get a lot of cool swag with a builder profile. So if you're looking for those cool jackets you see people wearing, hey, come back tomorrow for some swag. But if you're not at reInvent, you can actually get access to Amazon Q Developer. You can get access to a lot of cool things on community.aws. So definitely scan this little thing here and give it a shot. Yeah, thank you. Awesome. AJ?
Yeah, thanks so much. A lot of fun.
Thank you so much.
If you're looking to find me, I'm just AJ Steinberg on every platform, including Twitch.
Oh, and MySpace.
The head scoopers.
Friends, don't go anywhere. More content coming up. Bye.